Hello, class, and welcome. Today, we are going to be diving deep into a really powerful tool from calculus that has huge implications for business analysis, the product rule. Now, I know what some of you might be thinking, another formula to memorize. But I want to encourage you to see this differently. We're going to treat this not just as a piece of math, but as a powerful analytical framework for understanding the dynamic, real-world markets you'll soon be working in.
So let's start with a classic business problem, one that every manager faces. Picture this. You're in charge of a new product launch. To get more customers, you decide to lower the price. And it works. Your sales volume starts to climb. But now you have a puzzle. Both your price and your sales quantity are moving targets. They're constantly in motion. So how in the world do you calculate the precise impact on your total revenue at any single moment in time? This is exactly where our gut feelings can lead us astray, and where rigorous mathematics becomes absolutely essential.
So here's our game plan for today. We're going to follow a very logical path to really master this. We'll start by framing the conceptual challenge that businesses face. Then, we'll introduce the elegant mathematical solution that calculus provides. We'll walk through a pure math example to build up our skills and confidence. Then, apply it to a detailed business case. And finally, and this is crucial, we'll cover some common pitfalls to make sure you really have this down cold. Okay, let's begin. Section 1, the interdependence challenge. And you know, the subtitle here really says it all, when two variables drive one outcome. Because in the business world, our key metrics, things like revenue, profit, cost, they rarely ever exist in a vacuum. They are almost always the product of multiple interconnected variables that are all changing at the same time. And that is the heart of the challenge. I mean, think about the most fundamental formula, total revenue. We all know it's just price times quantity. Simple, right? But in the real world, in a dynamic market, both price and quantity are functions that can change over time. So just multiplying them together doesn't tell us the rate of change of our revenue. We need a way to understand how the change in one variable interacts with the level of the other, and vice versa. This is precisely the problem that the product rule was designed to solve.
And that brings us perfectly to our next section. To solve this interdependence challenge, we need a very specific tool from our differential calculus toolbox. It's called the product rule, and it's specifically designed to find the derivative, or the rate of change, of a function that is itself the product of two other functions. So let's dive in and see exactly how this thing works.
All right, here it is. Now, don't just see this as a string of symbols. Let's really unpack the logic. The rule is telling us that the derivative of a product is not just the product of the derivatives. Instead, it's the sum of two distinct effects. The first term, g prime times h, measures the impact of the first function changing, multiplied by the current level of the second. The second term, g times h prime, measures the impact of the second function changing, multiplied by the current level of the first. It beautifully captures the total combined effect of both things changing at once. Okay, before we apply this to our business scenario, we need to build some muscle memory. We need to get the mechanics of this down perfectly. So this next section is all about a pure mathematical walkthrough. Let's just focus on the process and make sure we are all comfortable with how to execute the formula correctly. Let's work with this function here, f of x equals x squared times sine of x. You can see it's a perfect candidate for the product rule, right? It's clearly a product of two simpler, distinct functions. We have our algebraic part, x squared, and our trigonometric part, sine of x. What's great about this is that it's just a methodical process. There's no guesswork. Step 1, you clearly identify your two functions, g of x and h of x. Step 2, find their derivatives, g prime and h prime. Step 3 is the key. You carefully substitute each of these four components into the product rule formula in the correct spot. And then step 4, you just simplify what you have. If you follow this step-by-step procedure, you'll be accurate every single time.
Fantastic! Now that we have the mechanics down, it's time for the really exciting part, seeing how this mathematical tool becomes a powerful instrument for strategic decision-making in business. Let's move into a real-world application.
So, let's go back to our tech firm. They've launched a new gadget. Their strategy is dynamic. They're going to gradually lower the price over time to capture more of the market. At the same time, their marketing campaigns are kicking in, so sales volume is growing. The critical question for the leadership team is this: what is the instantaneous rate of change of our revenue? In business and economics, we have a name for that. It's called marginal revenue. Now, to analyze this mathematically, we need to model the situation with functions. Take a look at this table. We're modeling our price, P of t, as a function of time, where t is the number of weeks since launch. It starts at $500 and drops by $5 each week. Our quantity, Q of t, starts at 1,000 units sold per week and increases by 20 units each week. Our total revenue, R of T, is simply the product of these two changing functions.
So just like in our practice problem, the first thing we do is identify our components. Our first function is price, P of T. Our second function is quantity, Q of T. Then we find their derivatives. The derivative of price, P prime, is -5. That makes perfect sense, right? The price is decreasing by $5 per week. The derivative of quantity, Q prime, is +20. Again, logical. Sales are increasing by 20 units per week. Now we have all four pieces of our puzzle.
And now, we simply substitute these components into the product rule formula to build our marginal revenue function. Look at what we've created here. This single function, R prime of T, is incredibly powerful. It allows us to calculate the instantaneous rate of change of our revenue at any given week. This isn't guesswork. It's a precise tool for making informed decisions about pricing, marketing, and overall business strategy.
All right, let's put it to the test. Let's say we're 10 weeks into the launch. The board of directors is meeting and they want to know, is our strategy working? Are we gaining or losing momentum? To answer that question with data, we need to evaluate our new marginal revenue function at T equals 10. So we plug in 10 for T, we run the numbers, and what do we get? We get positive $3,000 per week. This means that at that specific moment in time, at the end of week 10, our company's total revenue is increasing at a rate of $3,000 per week. The positive effect of our growing sales volume is more than canceling out the negative effect of our dropping price. It's a clear signal. So, let's put on our executive hat for a moment. As the CEO, what does this number tell me? It gives me a clear, quantitative signal that our strategy is working. The growth in sales is powerful enough to more than offset the drop in price per unit. Now, armed with this data, I can make strategic decisions. I can go to the board and say with confidence, we should stay the course. Or perhaps, this is working so well, maybe we should consider lowering the price even faster to accelerate our market share growth. This is exactly how calculus drives high-level executive decision-making. Okay, this brings us to a very important final section, because as powerful as the product rule is, there are a couple of common traps that students often fall into. So let's talk about these mistakes, because understanding them is the best way to make sure you avoid them in your own work. The number one mistake I see year after year is students just differentiating each function and multiplying the results together. That is fundamentally incorrect. It completely ignores the interaction between the two functions, which is the entire point of the rule. Another common error is simply forgetting the plus sign that connects the two terms. So, here are my tips for you. 1. Always write out your four components, G, H, G prime, and H prime, before you even start the calculation. It keeps you organized. And 2. Remember this rule applies anytime you have a product of functions, whether it's revenue, compound interest, or any other scenario. So, what's the big picture here? What's the main takeaway? The product rule is so much more than just a formula to memorize. It's really a mental model. It's a framework that helps you understand how interconnected forces drive change in any complex system. And believe me, whether you go into economics, finance, or operations, the ability to think in this structured way will be an incredibly valuable asset. So I'll leave you with a final thought to reflect on. The product rule is all about measuring the net result of interconnected, changing variables. So I ask you, what are the interdependent factors that will define the future of your career? Your skill set, the demands of the market, emerging technologies, they're all connected and they're all changing. How can you use this way of thinking to navigate the complexities that lie ahead? Thank you.